So we'll start. Dr. Sajad.
Okay, sir. Okay, sir. Good afternoon,
Okay.
participants. Good afternoon, participants. Welcome to the fourth day of the Faculty Development Program. We are privileged to have Professor Ejaz Masih sir with us today, and we are going to focus upon the statistical research today. I take this privilege to introduce Professor Ejaz Masih sir. Professor Ejaz Masih is a professor of education in the Department of Educational Studies, and presently he is the Dean and Head of the Department in Jamia Millia Islamia in the Department of Educational Studies. His area of special interest are curriculum studies as well as research, which he has been teaching since last 30 years. And during his professional life of about 3 decades, he has established himself as a well-known expert of research methodology. He has been involved in teaching research methodology at the master's and beyond that up to the PhD level for the last 28 years. He has a background of chemistry as well as sociology. So better we can say that he is very good at social chemistry as well, we can say that. To his credit, he has 7 commissioned research projects, 21 PhDs, 12 MPhils, 70 and more MA dissertations, 9 books, 25 research articles, 16 modules, 26 invited lectures, and several international and national conferences. He had been remained a member of several academic bodies and also the honorary director of Ansari Health Center and a member of API committees. We welcome you, sir. And today his deliberation is upon inferential statistics in education. So welcome you, sir, on this faculty development programs. Over to you, sir.
I think very good afternoon to everyone, and particularly the organizer, Professor Loknath Mishra, Dr. Sajjad, and all others who are organizing this faculty program. I am sure the participants are also very learned colleagues, and I welcome you all. And please don't trust what is said by Dr. Sajjad, because it's our tradition that we say some 5 words for whosoever is being introduced by a person. Anyhow, I am at least very clear in my mind that I am not here to teach anything to any of you, but I am here to share my own experience with you, and with this presumption that shared learning experience is better than the individual learning experience, and perhaps there are some empirical evidences are also available that say that shared learning experiences as compared to individual learning is more long lasting. That's why we will try to interact with one another and create an environment which we call the shared learning environment, and hopefully in that situation we will be in a better position to understand and reflect upon some of the issues that are emerging when we talk about statistical analysis of data. Before starting the statistical analysis or the use of statistics in research, I have some definitions of research, and don't consider that these are the definition, the ideal definition, but some of the features of research which I need to use during my presentation, and that's why I took these definitions just as a representative sample of many definitions available for research. I am very clear in my mind that you know what is research. That's why I'm not going to the 2 standard definition. One is given by the Cook, one very famous book, and another by Karlinger. Both are the writers of 2 research methodology book. Hopefully many of you are all aware. Here I am having one operational definition of research. And my purpose is of giving this definition is not that this is the definition which is theoretically very sound definition, but my purpose is when we will interact with one another, perhaps this definition will operative to all of us. And when we communicate each other, perhaps this definition will be a workable definition. And when I will use the word research, at least this much thing I am having in my mind. And when I communicate to you, the same should be communicated to all of us. That's why I am leaving the first two definitions. I am coming to the third definition, which is not a theoretical definition, but basically an operative definition, and which will be operational during my presentation. And I try to operationalize research here just a systematic, planned, and rigorous. These are the three words which I have used. That research is always a systematic effort. It can never be unsystematic. The moment we say systematic, it means automatically there is a logic behind it. There is some order behind it. There is some basis of doing first this, after that the next. So always there is a logical sequencing and logic, there is rationality behind every action which any researcher wants to take. So research is always a systematic effort. And perhaps this is the characteristics of research which differentiate research from many related terms. Say, for example, discovery. Discovery may be possible through systematic research. It may also be possible without research. So discovery may be sometimes through systematic effort, may be sometimes not through systematic effort. Madame Curie was roaming and she found the radioactive element. That was not through research. Second thing what I want to highlight is research is always a planned effort. It can never be unplanned. And this is the justification for preparing research plan or research proposal in advance. That planning means, for a layman language, planning is to think about something, what, why, how, when, prior to taking any action. That's why prior to starting research, we plan about all these questions. We try to answer all these questions, why, what, when, how, and that is being reflected what we call the research proposal or research plan. The next very salient feature of research is that research is primarily a rigorous effort. It means research is never an easygoing effort. Anyone who is interested of an easygoing person, that may not be a suitable person to become a researcher. So research that requires some efforts, some serious efforts, some labor, and that sometimes tires a person. That's why rigor is also another very salient feature of research. But all these things we do for what purpose? Primarily to make known whatever is not known. And there is another secondary function of research is also there, which is to verify whatever is known. But as very clear to all of us that we rarely verify anything and everything. We verify only when there is some suspicion, some doubt. It means whenever we find some contradictory evidences about something, only then we try to verify it. That's why if there is some contradictions, there is some confusion, there is some contradictory evidence available, we adopt a systematic plan and rigorous effort to verify that known also. So primarily research is for making known whatever is not known, and the secondary function of research is also to verify unknown about which we are having certain suspicions or doubt. With this operational definition of research, we will try to proceed further. as very clear that hopefully you have already exposed to research paradigm. Many of you already very much aware about research paradigm. I am not talking about much about research paradigm. Basically, I am only concerned about here the two approaches of research broadly, which we call as quantitative approach and qualitative approach. Here also, I am not at all concerned about qualitative approach. Please don't consider that I will talk anything about qualitative approach. So my focus is entirely only on quantitative approach during this discussion or presentation. There are certain features of quantitative approach which one should keep in mind whenever we discuss the quantitative analysis, or better to say statistical analysis of quantitative data. The one feature of quantitative research is that it talks about objectivity. It's concerned about objectivity. And objectivity means researcher is no way interfering, means his or her likes or dislikes or his or her preferences should not be the part of his or her research. So completely unbiased about whatever is coming, how it is coming. That's why objectivity is another feature that is inbuilt in quantitative research. And because objectivity can be ensured in a very specific manner when we try to quantify something, and ideally when you use some measuring rod to measure it. It means quantification and measurement are the two basic tools through which we try to transform the data into an objective form. Very simply, you can understand that if I put before you a question that how far is the nearest railway station from where you are sitting at this moment, the answer may be of many types. One answer may be it's not too far, it's nearby, it's just for a few minutes. But if you make a statement that from where I am sitting here, my nearest railway station is 16.2 kilometers, say for example, then you can kilometer. To understand this, the notion of 16.2 kilometer, only thing what is required to you is that you understand the meaning of 1 kilometer. If you understand this unit, obviously you will immediately understand that perhaps 16.2 times to that 1 kilometer is the distance from this, and it is not stretchable, it's not subjective, it doesn't depend upon your perception of near or far off place. On the other hand, if you say not too far, so far, it depends upon your own perception. For example, if I ask a baby who is very small baby and ask her to walk from even 2 meter distance, she will say it's too far. And it's not at all a distance for your perception. That's why it depends upon these kinds of statement depends upon the person who is speaking and the notion, the context he or she is having. So objectivity and can be ensured through quantification and measurement. Another very important dimensions of this particular kind of thing, which we call the precision. And when we talk about precision, I mean here in more specific term, the mathematical precision. Precision is having at least the 2 features that we should keep in mind when we understand the nature of quantitative data. On the one hand, precision means the briefest explanation. So any explanation which is briefest is the most simple explanation. But merely having something as brief is not enough, but the another characteristic is exactness. So brief plus exact means the precise, and because expressing in a mathematical term, things become more precise. That's why I often say that mathematics is a language. The difference between other language and mathematics is that it is more precise language, because it can convey briefly the thing, and it can also convey the things in a more exact term. That's why precision, that is also ideal for a quantitative analysis and quantitative data. Another important thing which we often not take into consideration, that whether I will go for the quantitative analysis or I will not go for the quantitative analysis, the decision is yours as a researcher. How? That at the time of formulating the research problem, and more so when you are formulating the research objectives for your study, you almost decide that whether you will go for the quantitative analysis or you will go for the qualitative analysis. That's why at the time of formulating research problems and writing research objectives, you to a large extent clarify that what kind of analysis plan you are having in mind. I am not talking about the many ontological and epistemological issues which are concerned with the research paradigm at the moment, but I am more of a practical side, only talking about practical aspect of this. Theoretical debate may be there, and that is also very interesting debate. I am not concerned about for the time being about those kind of issues. That's why the third thing is that the kind of response you are having through the administration of the tool, that will nature of tool will also decide that whether you will go for the quantitative analysis or not. That's why I wrote here that mostly in the quantitative analysis, the kind of tool which you use is mostly the close, which gives you the close-ended response. Would you like to take T now? Just now, your answer may be yes or no. And I decide that if somebody say yes, I will give 1. If somebody say no, I will give 0. So closed-ended response, putting the yes, no, there may be in between, which I am not taking into consideration. That may be the limitation of that kind of closed-ended response. Now, in a mostly quantitative research, we try to prefer the bracketed kind of study. Why bracketed kind of study? Because I am mainly being a quantitative researcher, my focus will be on the variables. And you understand the meaning of variable. Simply that varies, that is having more than one value. So I am interested to measure that value and try to find out its relationship, its dependence, its influence to other variables. That's why I am trying to keep aside all those variables that may influence the variable of my interest as a researcher. Just the two things. That's why ideally we want to do the controlled observation, which we call as experimental research. Or another very important issue when we talk about the quantitative research is that what we call the nomothetic approach. My focus will be to make a generalization. I am not interested to describe whatever is existing situation in detail, but from picking up the representative sample, I want to generalize. Nomothetic means itself that leads to generalization. Because mostly the researches are carried out by taking the sample, except the census. All other studies are based on sample. And if my focus is on generalization, obviously I will try to take that kind of sample which really represent the population. So representativeness of sample is very crucial in quantitative research because the focus is on generalization. And because precise observation and collecting data in a more objective and precise form, that's why the tool is extremely important in quantitative research. Whether it's a reliable, dependable, and valid tool you are having or not, and there are many means, ways of establishing reliability and validity. Even some statistical measures are required to establish reliability and validity of tools. So only a dependable tool can be used when we talk about quantitative research, which is extremely crucial for any quantitative research. And obviously, we apply the rigorous statistical treatment to data to analyze this, whatever is the focus for the present discussion. So with this introductory note, let us proceed about just the data or statistical analysis. Just as a beginning, so we can broadly categorize the three stages of any research. The first is planning of research. The second is collection of data in a research. And the third is analyzing the data, whatever we have collected. So our task starts from when we have collected the data. I am not talking at the moment about how we standardize the tools. That may be another area which we may talk in some way or other, but that requires a different kinds of discussion. So basically, the data means nothing but set of information. And data can generally be of two types. Numerical data means which can be expressed in the forms of numbers or numerals. And non-numerical data. If I ask someone, what's your name? The answer will be some name which is non-numerical nature. But if I ask how many participants are attending this webinar or this e-conference, the answer will be a number. So information may be in the forms of number, information may be in the forms of non-numbers, non-numerical. Now there is another situation also. When originally the information or data is in non-numerical form, but we can translate them into a numerical form. For example, suppose I collected information from 3 different religious groups. Say Hindu, Muslim, Sikh. And now I put a code, Hindu as 1, Muslim as 2, Sikh as 3. Now I replace the numerical data, non-numerical data into a numerical form. So sometimes translation of non-numerical data into numerical form is also possible. So with that, directly we get the data in the forms of numerical, in the forms of number, or we in the forms of numerals, or we translate it into in the form of number. Now the numerical data can also be of 2 types. One we called as enumeration data, means the data which is based on counting. And there is another kind of data which we called as metric data, means which is based on measurement. For enumeration data, the answer is always a number only. How many participants in this webinar? The answer will be a number. But if I ask you what's your height, And if you say something, say 5.6, is meaningless unless and until you mention the unit also. It means metric data requires a measuring rod, and on the basis of this, you will compare with that measuring rod, and ultimately you get how much. So unit is required for the metric data. Statistics primarily deals with enumeration data. And the characteristics of enumeration data is that it can be easily transformed in the forms of class interval and frequencies. Means you can group the data into different groups, and within a particular group, how many individuals or how many subjects lie, that will reflect the frequency. That's why in statistics, primarily we deal with enumeration data, but if all the metric data are in the same unit, we may take the unit as a constant and we deal metric data just like enumeration data. So statistics basically dealing with enumeration data which can be represented in the forms of class interval and frequency. Hopefully you all know all these things, but we can also deal with, or statistics can help us in dealing with, in analyzing of metric data, provided that all data are in the same unit. What statistics can do, that it can help us in collection, presentation, analysis and interpretation of quantitative data. How? We will try to understand. The first thing what statistics can help us is the condensation and summarization of data. If we have bundles of information, it's of little use unless and until we categorize them in some meaningful form. One way I already cited or discussed, that is in the forms of class interval and frequency. That's why raw data can be transformed into group data. Clustering a number of subjects together gives some better meaning to understand that group as a whole with a little effort. That is one beauty, that way the statistics can help us. Another thing is that statistics also help us to translate these data in a pictorial form, in a graphical form. And maybe many kinds of graph, whether it's a histogram, whether it's a pie diagram, or many others, that is also another way of dealing with data. Now, come to the next thing, what I said, that to analyze the data, there are three considerations which should be kept in mind, that how do we formulate the objectives, how do we select the sample, and what type of tool I am using. These three major considerations of research will decide that what kind of analysis we can do. Many times this happens that we do all these things, we have already set the objective, we have already selected, even we have collected the data by administering the tool, and then we come and approach someone that, no, I have to analyze and I have to use this statistics. I am having my personal experience that many of the people come from even the other universities and they say, sir, my guide has asked to contact you and tell me that how to analyze these. Then after going through, I suggest that only this you can do. No, sir. My supervisor has said that you have to use some ANCOVA, some ANOVA, sometime even regression analysis. I said, sorry dear, it's not possible now. So the important thing is that what actually you want to analyze, that will be almost decided. There may be slight variations after that also, but almost decided when you frame the objective, when you select the sample, and when you decide about the tools. That's why these three major considerations should be kept in mind. When you are deciding about these three, you should keep in mind that in what way you want to analyze the data. Am I clear or not? I think it's too simple. Nothing is abstract. Now, come to the actual analysis of data. Basically, statistics is having broadly the two roles. And accordingly, we divide the statistics into two kinds of statistics. One kind of statistics we called as descriptive statistics, and another kind of statistics we called inferential statistics. At this moment, what I want to say that perhaps now, as a researcher, there is not much need to know how to actually compute or calculate different statistical measures. Because fortunately, we are having the supportive tools in the forms of statistical packages using computer. The things can be analyzed very easily without much effort. But please keep in mind that your package, your computer can't tell you that which statistical measure you have to calculate or compute or how to analyze the data. That's why as a researcher, it is our responsibility to decide that how we will analyze the data. So understanding of the basic assumptions, notions attached to any specific statistical measure become more important now as compared to how actually compute the different statistical measure. Keeping that in mind, I am not devoting much time on how to compute, but because that is more of a mechanical kind of activity, but my focus will be that why a statistical measure one should be used and not the two. So that will be the focus of my further discussion. Now let us quickly talk about descriptive statistics. When we talk about descriptive statistics, the very first thing that is coming into our mind is measures of central tendency. And in class 8 now we are talking about mean, median, and mode, which are considered to be the measures of central tendency. Basically, the measures of central tendency reflects or say about that as a whole, what is the characteristics of a group? Or if we compact the entire group at a single point, we may say at the center of gravity, how do it reflect? How do it signify? What kind of characteristics group as a whole is reflecting? That's the purpose of this statistical measure, which combinedly we call as measures of central tendency. As you all know, basically the mean is nothing but the arithmetical average. Means adding each scores in any distribution divided by the number of scores, we can get the mean. It means the mean is affected by each and every score in a particular distribution. And if we have in the forms of group data, means class interval and frequencies, and some class intervals are open-ended, means the highest point is not known to us, or the lowest point is not known to us. In that situation, perhaps we are unable to calculate the mean. So, number one, that mean is affected by each and every score in the distribution. So any single score, if changed, the entire mean will be disturbed. Second thing, that if the end point of a class interval is not known, we cannot calculate mean for a group data. These two considerations we should keep in about the mean. Second kind of descriptive statistics, which we generally called as median, it is also an average, but it's a positional average. Technically, we define below which 50% cases lies. So it's point or a score below or above which 50% cases lie. As very clearly reflected, that median is a positional average. Where is the 50th position? That's why if you change the extreme scores from the lower side or higher side, there will be no change in the median. I have just put one example. Suppose there are 5 scores in any distribution, 5, 10, 15, 20, 25, and if we calculate the mean, it will be 15. And if you calculate the median, it will also be the 15. But now the second distribution, if I say 5, 10, 15, 20, and 5, 25, the mean will no longer will be the 15, because 5 plus 10 plus 15 plus 20 plus 5, 25 divided by 5 is not equal to 15. But if you talk about the median, it will remain 15. So what I want to say, that if there are extreme scores, mean will fluctuate a lot just because of a single score which I have changed. But median is not affected by those extreme scores. That's why we should depends on mean in case of the distribution is both sides of similar kinds of having deviations and not having any extreme score, positive side or negative side. But if you calculate mean in that situation, perhaps it will be a very misleading kinds of notion reflecting the characteristics of the entire group as a whole. That's why in that situation, what we do is we try to prefer the median as a measure of central tendency, because it is not fluctuating just because of changing one extreme score in, and that's why it gives a better measure as compared to mean. So decision about which measures of central tendency I should keep at what time will be decided about nature of distribution which I am having. The next, the last is generally the mode, which is considered to be the crudest measure of central tendency. And if somebody is interested just immediately to know about some measures, generally we depends upon the mode, and it is known as most frequently recurring value in an ordered distribution. That's why when we quickly need, or we need to depends more of a general kind of thing where there is a little question of very in-depth understanding about the variation. For example, suppose if you are interested to talk about that, what is the income of here I put an example, a young law graduate income. Then here we are not calculating mean or median, but just quickly I say the mode, because the most popular is average will be the income that will reflect that perhaps this is mostly the young law graduate is getting. Or if you are constructing flats, generally the average family size, we just calculate the mode, because the popular family size on the basis of which we decide that this should be the size of a flat if I am developing for a specific group. But for serious research kind of thing, generally we rarely depends on mode as a measure of central tendency, but when quick and immediate a general kind of description you are needed, we may go for the mode also. Now, the next measures, which we call the measures of dispersion or measures of variation. This is another descriptive statistics. There is a limitation of measures of central tendency, whether we talk about mean or whether we talk about any of the measures. Say, suppose we are only having the two subjects in a group, two students. One student scored 0 in a test of 100 marks and another scored 100 in that marks. What will be the mean? Obviously, the 50 will be the mean, 0 plus 100 divided by 2. What will be the interpretation? That on the average, the group answered half of the question correctly or is scoring 50%. What is the reality? That no one is average in that group. One is very poor, another is getting the 100%, so very excellent. So sometimes merely measures of this central tendency gives a wrong notion. In this graph, I try to show this, that one situation may be 0 to 100, another situation may be 20 to 80, means 20 plus 80 divided by 2, again 50, then 40 plus 60. So when we talk about 0 to 100, obviously the dispersion or separation from one score to another is much bigger, much higher. So more distribution is scattered as compared to 20 and 20 to 80. But 40 and 60 is comparatively closer to each other. It means we need another kinds of measures which can reflect up or show the characteristics of homogeneity or heterogeneity within a distribution, which we call as measures of dispersion or measures of variations. And generally, we talk about 4 different kinds. You all know, I don't have too much talk about. Range, which take into consideration from the higher and lower difference between higher and lower. Similarly, the mean deviation, which talks about the deviation of each score from the mean divided by the number of score. We can find out the mean deviation, but standard deviation is average of the square of the each deviation, as I put here, summation of x minus m whole square divided by n. Forget about the formula, don't bother about the formula if you are having any problem. Basically, the difference between mean deviation and standard deviation is that sometimes mean deviation may be a misleading thing. For example, what the earlier example 5, 10, 15, 20, 25 I gave, if you will calculate mean deviation, you will find it is 0. It means there is no deviation. Why it is coming? Because half side from the mean, they are 5 and 10, and exactly the difference from mean is of 10 and 5. Similarly, when we say 20 and 25, the difference is on the other side 5 and 10. And that's why ultimately the mean deviation if you take the average, that will come 0. So mean deviation may be misleading some kind of things, because there are deviations, because from 5 to 25 scores lie. So it's not a homogeneous that all scores are not same. But if you will calculate mean deviation, it will come 0. That's why it's misleading. So we depends more on a standard deviation. This is another measure, and which is most frequently used measures of dispersion. And when we will come to the inferential statistics, you will find that on the basis of standard deviation, many further calculations are being carried out. That's why whenever we want to calculate further inferential statistics, generally we always calculate standard deviation as a measure of variation. There is a fourth kind of measures of dispersion also, which we call the quartile deviation. And basically, it talks about the deviation between or difference between the first quartile and the third quartile. First quartile means below which 25% cases lies, and third quartile means below which 75% cases lies. It means quartile deviation take into consideration only from Q1 to Q3. So neither above 75% or below 25%. So mid 50% cases are taken into consideration in quartile deviation. So just like a median, quartile deviation also not being influenced by extreme scores. So when we are having extreme scores in a distribution, standard deviation may not be a very suitable measures of dispersion, and generally we go for the quartile deviation. Now, the one very important measures of a descriptive statistics, which we call the measures of correlation. And perhaps this is the most frequently used statistical measure as a part of descriptive statistics. Correlation means association between two or more than two variables. When only two variables are involved, we called it a bivariate, means where only there are two variables involved. And when more than two variables are involved, we call it multivariate correlation. Now there is another thing which we should keep in mind, that correlation may be of two types. One kind of relationship is just association. Association means you cannot decide that which depends on what. It may happen that the two variables are depending on the third variable. So the relationship between two variables is not the causal. You cannot say that this is the cause of another or this is the effect of another. But only thing we say that two are changing with the same rate or changing together. But why they are changing? Not because of another. It may be because of some third variable or unknown variable, that may not. But there is another kind of relationship which we called as causal relationship. Means this depends on that. When we call that causal relationship, in that situation, one will be independent variable, another will be dependent variable. the most popular, no, another notion. What is coefficient of correlation? As a statistical measure of correlation, generally we calculate coefficient of correlation. Coefficient of correlation is nothing but basically an index or a ratio which can tell us the degree of relationship, extent of relationship. So how much the two variables are related if we talk about the bivariate relationship, so extent of relationship. The most popular coefficient of correlation is generally known as Pearson product moment coefficient of correlation, which is represented by small r. But there are certain confusion which we often use during interpretation of correlation or interpretation of, better to say, coefficient of correlation. Please keep in mind that coefficient of correlation can never be interpreted in terms of percentage or in terms of multiple. For example, if this is not capital R, it is by mistake automatically sometime during typing the first letter is written as capital. So it's a small r. So sorry for having capital R. So R is 0.5 means never that the two variables are having 50% relationship. So you cannot interpret like that. Or you cannot interpret that if the two coefficient of correlation, one is 0.5 and one is 0.25, that 0.5 is half of the 0.25. And 0.25 is the double of the 0.5. So coefficient of correlation can never be interpreted in terms of multiple or in terms of percentage. This is a caution which we should keep in mind. Second important thing is that you cannot say in absolute term that this is a high correlation or this is a low correlation. In some situation, a very low value of coefficient of correlation may be a significant coefficient of correlation, and in some other situation, even a moderate kind of coefficient of correlation may not be a significant coefficient of correlation. Because coefficient of correlation also depends upon the size of the sample. That's why interpretation of coefficient of correlation value, which ranges from -1 to +1, -1 represent the perfect negative correlation, +1 reflect the perfect positive correlation, 0 stands for no correlation, any value in between is reflecting imperfect correlation, either negative or positive. So please don't interpret any value of coefficient of correlation as very high or very low in absolute term, but in relation to the context, means the size of the sample and statistically significance of that sample, which we will discuss after a few minutes. We can interpret the coefficient of correlation. Now, there are many other coefficients of correlation. So decision about that which coefficient of correlation one has to calculate is extremely important to understand the relationship between two variables. And if you calculate a wrong coefficient of correlation where that may not be used, then it will be a very misleading kind of interpretation. For example, the most popular coefficient of correlation, which we called as Pearson product moment coefficient of correlation, which is generally represented by small r. The first condition for this is that it is a bivariate correlation. It means this coefficient of correlation can be calculated only when there are two variables. And we are interested if to calculate the degree of relationship between these two variables. But This can be calculated only when, please keep in mind, only when the variables are continuous. What is the meaning of continuous variable? There are two kinds of variable. Another kind of categorization of variable we sometimes call as categorical variable and continuous variable. Pearson product moment coefficient of correlation can be calculated only when the variables are continuous. Continuous means that it is not the kind of variable which are put under different categories and there is a break in between the two. Say for example, the male and female. Nowadays we are saying a third gender also transgender, but male, female, say third gender also. But there is nothing in between male and female or male and third gender. So these are the three exclusive categories. But continuous variables is that kind of variable where whatever the two consecutive value of a variable we take, there is a theoretical possibility of another number. Say for example, if some score is 5, another score is 6, there is always theoretical possibility between 5.5, in between 5 and 6. If you talk about 5 and 5.5, there is always possibility of 5.51, 5.52, 5.53 and so on. So theoretical possibility of any other number in between the two consecutive number cannot be ruled out. If that kind of variable we are having, only then we can calculate the Pearson product moment coefficient of correlation. Second important thing is that the two pairs of variable, because say x and y, so two variables x and y, and within each we are having the different pairs. Suppose individual 1 and individual 2 scores in x this, score in y this. The two pairs are not necessarily related, but it must be unrelated, independent, unconnected. That is another characteristic. And the most important characteristics, the relationship should be linear, means that can be reflected in the forms of a straight line or near to a straight line. It means if the relationship is of another kind, means say the wave-like nature of relationship. In that situation, we cannot calculate the simple product coefficient. Similarly, the other kind of coefficient of correlation also having the certain assumptions, and if those assumptions are not being fulfilled, we cannot calculate. For example, another very common coefficient of correlation, which we call the Spearman rank difference coefficient of correlation. Generally, it is used when the samples are small. And small samples in the language of statistics is called any sample less than 25. Some books say less than 30. Generally, we calculate only then. And the other important assumptions are that score is in the forms of rank or can be transferred in the forms of rank. Only then we can use this. Similarly, there are partial, I will come later. Similarly, there are another kind of coefficient of correlation which we call as biserial and point biserial correlation or tetrachoric and phi correlation. These all are by variate correlation, but it depends upon that one, as we pointed out, that in Pearson product, both variables should be continuous. In biserial and point biserial coefficient of correlation, one variable should be in dichotomy, means which is having only the two values, male, female, pass, fail, like that. And other variable should be continuous. Only then we can calculate biserial or point biserial coefficient of correlation. The actual thing is that there should be difference between biserial and point biserial is only about the dichotomous variable, means which is the variable which is represented in the forms of two category. The biserial is artificial dichotomy. For example, we are having the examination scores and we categorize these scores as pass and fail. Say taking a score 33 as a pass mark, so only all those who scored above 33 or above will be passed and less than that are failed. So I artificially transform a continuous variable into a dichotomous variable, and point biserial is being used when the dichotomous variable is actually naturally in dichotomy, say male female, say rural urban, like that. Now there is another kind of coefficient of correlation which we called as partial coefficient of correlation. Partial coefficient of correlation means here I am interested to find out the relationship between two variables, but the influence or impact of a third variable we try to statistically controlled or statistically partial out. And fortunately, we have the statistical formula for calculating this very simply. For example, R12.3. This word dot is point is very important. It means R12.3 means it's the coefficient of relation between variable 1 and 2, where impact of or influence of third variable is partial dot or statistically controlled. And with this formula, we can very easily calculate, forget about the formula. But the only thing is that partial coefficient of correlation sometimes gives a very significant result, and sometimes because simple product moment coefficient of correlation gives a misleading result. For example, suppose we are having relationship between 1 and 2 variable as 0.3, relationship or coefficient of correlation between 1 and 3 as 0.6, coefficient of correlation between variable 2 and 3 is 0.5. So relationship coefficient of correlation between 1 and 2 is 0.3. But whether this is a real relationship or not, that can be verified only when we calculate the partial coefficient of correlation. And if you use this formula, you will finally find out that coefficient of correlation between variable 1 and 2 when influence of third variable is partial dot will come as 0. It means the relationship between 1 and 2 is misleading as 0.3, and it is not because the variable 1 and 2 are related, but because variable 3 is influencing both, and because of the combined influence on both, the joint influence of both the variable, this simple product moment coefficient of correlation is coming as 0.3. That's why sometimes partial coefficient of correlation give a better picture of relationship among the variables. Now, this almost I have said tetrachoric also. Coefficient of contingency is another kind of coefficient of correlation when all the variables meet. It is also a bivariate, means only the two variables, but both the variables in the forms of categories. Means rural, urban, male, female, If we want to see the domicile and sex relationship, we can calculate the coefficient of contingency. So both the variables are in categories. Categories may be 2 or more. Now there is another kind of coefficient of correlation which we called as the multiple coefficient. And it is of very much used in educational research, in other research, also in almost all social sciences. It's a very popular coefficient of correlation because rarely any one variable is influenced by a single variable. But fact is that any social science variable is influenced by a number of variables. If you go through the 70s and 80s, you will find that age was the age of doing research on correlates of achievement. So academic achievement was studied in relation to many variables. And if you or review the literature available, you will find that more than 100 variables are being found that these all are correlates of achievement. Now, which variable is influencing the dependent variable to what extent? Individual influence is not important, but the importance is that jointly how much they are influencing. That's why multiple coefficient of correlation is just like as I mentioned here, R1.23. Dot is very important. It means variable 1 is here a dependent variable. And 2, 3 are independent variables. So how much the variable 2 and 3 are jointly influencing the variable 1. The multiple coefficient of correlation, which is generally represented by capital R, reflects that. So R is basically the coefficient of correlation between variable 1 and 2 and 3 taken together. Here I am taking only the 2 variables as independent variable. You may extend to as many variables as you want. The only thing is that the computation will be more complex. So R1, 2, 3 and 4. It means 3 dependent variables, how much they are jointly contributing to 1. We can calculate this, and by using the simple product moment coefficient of correlation, we can calculate the multiple coefficient of correlation also. Here the important thing is that R squared is more relevant than just R. And R squared is known as coefficient of determinant. Means what is the proportion of contribution of the set of independent variable which are taken in calculating the multiple coefficient of correlation, we can tell us. For example, suppose R1.23 is if say 0.5. R square will be 0.25. It means 25% of the total variance is being contributed by only variable 2 and 3 in case of variable 1. So how much variance left? 1 minus 0.25 is equal to 0.75, and that what is not being predicted by these variable is known as coefficient of non-determinant, which is generally represented by k squared. And k squared is always equal to 1 minus r squared. So k squared and r squared both are important for us in interpretation of contribution of different variables, different independent variables on any independent variables. In a nutshell, this much I want to say about descriptive statistics. Just to conclude about descriptive statistics, it means that descriptive statistics basically describe the characteristics of a distribution in a more precise manner. That's why we can understand in a more objective and precise manner a specific characteristics of any distribution or a set of distribution. For example, measures of central tendency can tell us how far or how much the overall characteristics of a distribution is in terms of any variable. Similarly, coefficient of correlation can tell us how the two variables in a distribution are related. What is the degree of relationship? Whether that degree of relationship is high, low, positive, negative, etc. So, description in a more precise manner about the characteristics of a distribution is generally the task of any descriptive statistics. Should I proceed further? Do you have any queries till here?
Yes, sir. There are questions also. I mean, not a purchase question. It is basically some of the participants are requesting that can there be some.
Your voice is not very audible, dear.
Sir, is it audible, sir, now?
Yeah, a bit.
Wants to take up, wants you to take up some of the survey example to deliberate.
I am coming at the end, the research objectives, and that will highlight the use of each of them. Wait for a while.
Exactly, sir.
And exactly
Yes,
the last part is that only that I have formulated with the taking the exact research topic, and I try to have some research objective that will highlight that which statistics one can use.
So we can take up 10 minutes break as well, sir.
Yes, sir. Yes, sir.
Okay, if you want.
Yes.
Fine. I think now we should talk about inferential statistics, and basically except in census survey, we rarely conduct any research on the total population. We generally collect data from sample or do research on sample. Whether it's a survey or even any other kind of research. So we collect data from sample, but our interest is not that whatever findings we are having that should be confined to the sample, but we want to predict, infer, guess, estimate about the population characteristics. In other words, we work on sample, but our motto is to say about the population, to estimate about the population characteristics. In the words of statistics, any statistical measure which describes the characteristics of sample is known as a statistic. So mean, median, mode is product moment coefficient of correlation or any measures of dispersion. If we calculate for the sample, these are basically known as the statistic. But with the help of statistics, we want to guess, estimate, or predict about the characteristics of the population. Means we want to find out the characteristics in terms of a statistical measure about the total population, which is known as a parameter. in the language of statistics. In other words, we calculate statistics, but we want to estimate or predict about the parameter. Say, for example, if we use the abbreviation M as mean, which is the mean of any sample, say suppose I administered on 100 students any intelligence test, and I calculated the IQ value if that intelligence test measured the IQ. And if IQ came as, say, mean IQ as 110. Now with the help of this 110, I want to infer or estimate about what will be the mean value of the total population from where these 100 students were selected. So if we calculate originally the mean of the total population, that is known as parameter. And generally in statistics, we use the different abbreviation for that also. For mean, generally we use the letter mu as mean population, which is known as parameter. So with the help of M, we want to predict about the mean. Similar is the case with any statistical measure. So inferential statistics is basically the estimation of population by knowing the statistic. In other words, we want to describe the characteristics of population by knowing the characteristics of sample. So inferential statistics are those statistical measures which can help us to infer about the parameter, to help in guessing that whatever we are calculating about the sample, whether it fit in, whether it's nearer to that parameter or not. But please keep in mind, this estimation is based on principle of probability. That's why we can never say with 100% surety. We can say with 99.99 up to infinity surety, but we can never say with 100% surety. Because the moment we will say 100 with 100% surety, it will be certainty rather than probability. Entire inferential statistics is based on the principle of probability. Means, what is the possibility of this? And whenever the beauty of statistics is that, or beauty of inferential statistics is that, it's not only tells us that what is the value, what is the probable value of parameter, but it can also tell us that what are the possibilities of error in this estimation. So inferential statistics can tell us the two things. One is, what will be the value of parameter? And if we say this, what is the possibility of error in making this statement? But as I said, that the entire inferential statistics is based on the principle of probability. That's why the possibility of error of measurement is also there. One is probability in estimation, there is a possibility of error, and the second thing is that error of measurement because of use of tool. And as I said in the beginning, that here the reliability of the tool is very important, and reliability is technically defined as proportion of the true variance of the total variance. Means what is supposed to measure to what proportion of the total it is measuring. And there is no tool which is having no error variance. There will be error variance, but how little it is, that is the effort, entire effort of developing better and better tool. Another important thing is that, as I said, that the beauty of inferential statistics is not only telling us the probable value of parameter, but it also tells us that what is the possibility of error. That's why we generally talk about what is the possibility of sampling error, and which can be calculated by finding out the standard error of any particular statistics. Last thing about the inferential statistics before talking about inferential statistics is that the procedure of getting representative sample is very crucial, and that's why whatever the possibilities of sampling and non-sampling error involved in the process of sampling, that should be well known to us, and that should be taken care of, so that we may have as possible as a true representative sample of the population. And generally in statistics, we feel that the probability technique of sampling will provide a better representative sample. These are the certain things which one should keep in mind when talking about inferential statistics. Some more thing will come also. Now, there is another aspect, that all inferential statistics may be categorized into broader categories. One kind of inferential statistics generally we called as parametric statistics. And another category of inferential statistics we call as non-parametric statistics. Parametric statistics are those statistics which require certain assumptions to be fulfilled. If those assumptions are not fulfilled, we cannot use any of the parametric statistics. The very first assumption of use of any parametric statistics is that distribution should be normal. We all know the characteristics of normal distribution. Normal distribution follow a particular equation, but for the practically, we should keep in mind that if we represent that distribution in a graphical form, it will come in a bell-shaped, and it is having the same mean, median, and mode value. But actually, there may be slight variation, but near to same all this, and half of the subject should be positive side of the mean, the other half should be negative side, but ideally there should be a normal distribution. The second very important characteristic is that sample must be selected randomly. So random selection of sample is very crucial, and as we know that there are two features that any random sample, all probability samples are based on the principle of randomization. So there are two characteristics any random sample should have. The one is that the selection or rejection of any sample subject must be by chance. So chance is the only criterion to select or reject a sample. And that's why ideally every subjects should have equal chance to be selected or to be rejected. So theoretically, equal chance of selection or rejection of each and every unit of any population. Second important thing is that selection or rejection of one should not influence the selection or rejection of any other. These two primary features of randomization should be maintained. Only then we can say that it's a random sample. Fortunately, there are many probability sampling, and hopefully you may know the characteristics of sampling. Sampling itself is a very fertile area and a lot of discussions are required. I'm not at the moment concerned about this, but important thing is that for using any parametric statistic, one has to ensure that samples are selected randomly. The third characteristic is that if you are having more than one sample, each sample must be drawn from that parent population which are having homogeneous variance. Variance is what? Square of the standard deviation. So it's not the sample, but from where the population from where they are drawn, they should have almost similar or homogeneous variance, means square of the standard deviation. These are the three basic characteristics or basic assumptions. If these are being fulfilled, only then we can use any of the parametric statistics. But if any of these assumptions are not fulfilled, means if we are having severe doubt about the fulfillment of any of these assumptions, we can use any non-parametric statistics which do not require any such assumptions. That's why we sometimes call non-parametric statistics also the distribution-free statistics, because it doesn't require any such kind of assumption which is needed for the kind of distribution for using any parametric statistics. Now, I have jotted down here only some of the inferential statistics which are very frequently used in social sciences, including education and other social sciences also. And very quickly, I will talk about each of them, but please keep in mind, I am intentionally not talking about the calculation aspect of each of them. T-test is a parametric statistics which can be used when we are interested to compare the two means. So the difference between two group means, if we are interested to compare, say for example, suppose there are two groups. One group mean is say 50 on any criterion variable, let us say achievement test. Another group performed say on the same achievement test, say 55. So there is a difference of 5 between group 2 and group 1. 55 minus 50 is equal to 5. Now the important issue is t-test can tell us that whether this difference of 5 is true difference. True difference means if we administer the same test not only on the sample on which I have administered, but if I administered on the two different population belonging to these two groups, whether the difference will be always in favor of group 2, or it will be near to 5 or more than 5 or not. If I want to test this, we can use t-test. So t-test can be used to find out the significance difference between two means. Please keep in mind the word significance, statistical significance is a very significant in inferential statistics. Statistical significant means that whatever the value of any inferential statistics is coming, it is not because of just chance, but truly that exists. And if we repeat this exercise on the entire population or taking different sample again and again from the same population, the similar difference will come. So t-test can be used when we are interested to compare the two group means. In t-test, basically we calculate a ratio which is known as t-ratio, and generally it is calculated by difference between two means and divided by standard error of difference. Standard error of difference is another measure which can be calculated, and that depends upon the nature of sample again. But anyhow, the important thing is that if t-ratio comes significant, then we can say that yes, there is difference between two means, and whichever mean is higher in favor of that performance is better as compared to another. Similarly, the next inferential statistics, which we called ANOVA, or it is an abbreviation of analysis of variance, which means that we try to analyze here the variance. Variance, as I pointed out, means square of the standard deviation. When t-test can be used if there are only two groups. We can compare the mean of two groups only. But if we have more than two groups, we have to compare one pair at a time. Suppose if I am having 5 different groups and I want to compare the mean of 5 different groups, how many t-tests I have to calculate? 5 into 5 minus 1 divided by 2. N into n minus 1 divided by 2. So I have to calculate 10 different t-ratios. It may happen that after calculation of 10 different t-ratios, none of the t-ratios come significant, then entire effort will be wasted. That's why we have another kind of ratio in analyzing the variance, which is known as F ratio. So in analysis of variance, we calculate F ratio. It is also a ratio between the two kinds of variance, variance among the group and variance within the group. Among the group refers to the treatment effect. Suppose 1, 2, 3, 4, 5 groups are there, and M1, M2, M3, M4, M5 are the means of this. There may be two kinds of variances possible. One possible is because of these differences in different means, and another kinds of differences as a result of the different subjects within a group. So average of the differences of the different subjects within a group, if we calculate, that is known as within variance, subject variances within the group. So variance among refers to the variances due to treatment effect, and variance W refers to the variance due to subjects variation within a group. So if we calculate the correlated ratio between variance among and variance within, that is known as F ratio. If F ratio is significant, we can safely say that at least one group mean definitely differ with any other. In that situation, if F ratio comes significant, in that situation, we will be in a position to say that now we can calculate T ratios or use t-test to find out which group actually varies significantly with another. The next kind of statistical technique which is also very common, which we called as ANCOVA, analysis of covariance. I am trying to very simplify the things. There are a lot of things one has to talk about, and when we actually use it and use the computation process, we can learn many more things, but I'm avoiding at the moment. ANCOVA is basically the combination of the two. Analysis of variance means ANOVA plus regression. That's why first let us try to find out, to talk about regression. What is regression? Regression is basically a statistical technique on the basis of which you can tell us what is the contribution of one variable on another, means one independent variable on another dependent variable. And on the basis of this, knowing this contribution, you can predict the score without actual calculation. Means you are not measuring the two variables, but just you know the value of the independent variable, and on the basis of which you can predict what is the contribution on dependent variable. Now, regression, like correlation, it may be bivariate, it may be multivariate. Means if you are predicting for a effect of only a single independent variable on dependent variable, it will be a bivariate correlation regression. And if you want to predict a dependent variable by taking more than one variable, that is known as multivariate regression. So we can use this also. Now, ANCOVA is basically predicting. Prediction is on the basis of regression, and ANOVA can say that what is the differential effect of different treatment, whether it's significant or not. If we combine this, what we can do, that we can adjust the differential effect of any variable, which is not the variable of interest for anything. Say, for example, I am interested to compare the two group means. I am interested to compare the effects of two teaching methods, say for example, teaching method A and teaching method B. And my criterion variable is achievement. Obviously, my methods of teaching will be independent variable. Now, one may compare the two mean by using t-test simply, but it may happen that the difference is not because of the two methods are having differential effect, but it may be possible that difference is because of, say, differential intelligence. So the differential effect of intelligence can be controlled in the mean score of achievement by applying the regression component in this analysis of variance, and jointly what we call the ANCOVA. So ANCOVA means adjusting the differential effect of covariate, means that variable which may influence the dependent variable, but which is not the variable of interest. We can do this. Don't worry, you can understand very easily when we will come to that. Now, I am coming, just one moment. Just parallel to t-test, we are having the non-parametric statistics as chi-square or median test. When we are having suspicion or doubt about the regarding the assumptions of these variables, we can very easily adopt a median test or a chi-square to compare the different groups. The only thing is that here we do not require any those assumptions and even the variables are not in actual score form, but even the categories are given that above average, below average, like that. Even then we can use the chi-square or median test. Now, the important thing which we should talk about. Here, I have just taken one topic from an actual research, just to highlight that how to frame objectives so that we should be very clear that which statistical measure I have to calculate. The title I have put here is Study of Teachers' Role Performance in relation to teaching competency, professional interest, and teaching aptitude. There are 4 variables mentioned here. Role performance is one variable. Teaching competency is another variable. Professional interest is third variable, and teaching aptitude is the 4th variable. Obviously, the role performance of a teacher is the key variable, the focal variable in this title. The other 3 variables, we want to see what's the relationship with this role performance. Now, we can put as first objective to study the nature of relationship between role performance and teaching competency, role performance and professional interest, role performance and teaching aptitude. What do we mean nature of relationship? What I am interested to find out? What is the expectation? How do we fulfill this objective? Obviously, we will first calculate the coefficient of correlation. Now, making a decision about which coefficient of correlation I have to calculate will be decided by whether the measurement of these 4 variables are the result are coming as continuous or not. If all are in scores form, continuous score form, we may treat them as a continuous variable. If none are categorical variable, we treat all of them as continuous variable. If the samples are large and samples are selected randomly, obviously we may presume that the distribution is normal also. In that situation, we can safely calculate Pearson product moment coefficient of correlation for each of these pairs. Means 3 coefficient of correlation I have to calculate between 3 pairs of variables. Now the objective is to study the nature of relationship. There are 2 words, nature of relationship and extent of relationship. Coefficient of correlation is a measure of extent of relationship. So, no, not only that we will calculate the coefficient of correlation, but also we will find out whether this coefficient of correlation is statistically significant or not. So, we will significance of coefficient of correlation we will also calculate, which is not difficult to calculate. We can calculate, and now in any statistical package you will find out that whether it's significant or not. I am coming to the level of significance a moment later. So we will calculate the coefficient of correlation. Whether it's a significant or not, that will also be reflected if we will find out that what is the significance value. Second thing, the nature of relationship will be decided by whether it's a positive, whether it's a negative, whether it's a perfect, or whether it's an imperfect. Rarely we get any perfect correlation, means correlation as 1. always correlation comes as less than 1 theoretical, practically. So theoretical possibility is perfect relationship, but rarely we get a perfect relationship in any situation. That's why any value less than 1 will come. Now, if it's coming positive, we will say the positive relationship. If it is come statistically significant also, we will say positive and statistical significant relation. So if we will write after calculating this, we will define the nature of relationship. Okay. Now come to the second objective. That is very important. To perform is not a correct word. To find out the relationship of role performance with teaching competencies when professional interest and teaching aptitude are partialed out. Now what is very clearly written this objective? Role performance and teaching competencies, we want to find out the relationship between these two, but the two other variable, professional interest and teaching aptitude, are partialed out. It means here we have to calculate the partial coefficient of correlation. RPTC dot PI and TA. You can name 1, 2, 3, 4 also. So we will calculate R12 where dot 3 and 4 are partialed out. It means now here we have to calculate partial coefficient of correlation, and then we will also find out whether this partial coefficient of correlation are statistically significant or not. The rest two of the objectives are also of the partial coefficient of correlation. Only thing is that the other variable are partial out. RP remain constant because RP is a dependent variable. So writing this objective, what is the presumption? That role performance is a dependent variable and all other variables are considered to be independent variable. Please keep in mind, in partial coefficient of correlation, we have to decide that which is independent and which is dependent variable. So we can partial out also those variable which is independent variable. So role performance is considered to be the dependent variable. All the rest are considered to be independent variable. Now come to the same. Topic remains same. To study the combined effect, joint contribution of teaching competencies, professional interest, and teaching aptitude on role performance. So here we are interested to find out the joint contribution of 3 variable on 1 dependent variable. So 3 are the independent variable. We are interested to find out the joint contribution. It means here we will do the regression, multiple regression analysis, and finally we will calculate the multiple coefficient of correlation. Now, the next is to study the impact of teaching competency, professional and teaching aptitude on role performance. What does it mean? Now here we are not interested to find out the joint impact, but we are interested to find out whether this variable teaching competency is having a significant impact on role performance or not. Separately, professional interest is having contribution on role performance or not, or teaching aptitude is having. So in this situation, the kind of statistics we will use, definitely regression analysis, but stepwise, means we will insert one variable and then we will try to see its effect in terms of regression, that whether it is contributing or not. Now come to the next. Again, I have written one topic of one of the PhD study. One can write another topic also, so that's not the issue. But for my own convenience, I have mentioned here, but later on you may suggest some topic and we can identify. Title is A Study of Constructivist Learning Environment on Understanding of Mathematics in Relation to Creativity and Socio-Cultural Background. This is the title. So, a kind of learning environment created means a kind of treatment which we call the constructivist learning environment. And what is the criterion variable? Understanding of mathematics. But there are two other variables which are also taken into consideration. These are creativity and socio-cultural background. So again, 4 variables. Constructivist learning environment. Please keep in mind, in all quantitative analysis, all statistical analysis, variable is the key. So keep in mind the nature of variable. So first is constructivist learning environment, which is here clearly independent variable. Its impact on understanding of mathematics we are interested to find out, but in relation to creativity and socio-cultural background. Now try to understand the objective, which will highlight that what actually we are interested to find out. Objective is to study relative impact of constructivist and conventional learning environment on understanding of mathematics. Means there are 2 groups. One is exposed to constructivist approach of teaching, which here termed as constructivist learning environment. Another is exposed to conventional. So conventional teaching, which may be treated as a control group perhaps. So there are 2 groups, and criterion variable is understanding of mathematics. It means there may be a test, maybe a specific kind of achievement test which measures understanding of mathematics. So there will be 2 mean. Now we are interested to compare this, to study relative impact. Relative impact means comparing that which one is better than another. So here we may use the t-test simply. Because there are 2 means, and by using the t-test we use y and ANOVA one way I have mentioned here, because square of the f is equal to t. If other calculations are being done here, that's why ANOVA is written, which will be clear in the second objective if you will read. In the second objective, to study the interaction effect of creativity and constructivist learning environment on understanding of mathematics by the class 11th students. What is the man? Now here, how creativity is interacting with the learning environment and its impact we are interested to find out on understanding of mathematics. No, it's not just a simple thing that we are giving a treatment and its impact we are interested to see. But here we are interested to see the interaction of the two. What? The creativity as well as the constructivist learning environment. The joint impact of these two on understanding of mathematics. That's why no, it's not possible just by using one variable. Here we will use the factorial design where we can compare the different combinations or interaction effect also. You can understand very easily the interaction effect. Suppose different methods of teaching may be having a different impact. But at the same time, different teachers are also having different impact. Some teacher may be very good teacher, no matter whatever the methods is being assigned, his or her performance will be better. Some methods per se is good, and that's why it always gives a better result. But it is also possible that a combination of the two, a teacher who is more comfortable with a particular method gives a better result as we compared in isolation. From agriculture, you can easily understand this example. Suppose the variety of seeds. The different variety of seeds can give different kinds of yielding. Some hybrid variety gives a better yielding as compared to another variety. But different variety of seeds also requires different kinds of irrigation. And a judicious combination of the irrigation and variety of seeds gives the best result. So it's not just the variety of seeds impact or just the variety of irrigation impact, but it's the interaction effect of the two that is giving the better result. So we are also interested to study that interaction effect here, which can also be studied as a result of analysis of variance two-way classification. There we consider on the one hand the different methods here, the two methods, and on the other hand the creativity. Now, similar is the situation that in place of creativity here, interaction with socio-cultural background and the constructivist learning environment on understanding means interaction between socio-cultural background and constructivist. Now the third here, in the fourth objective, we are taking both the variables, means creativity as well as socio-cultural background together, and I am interested that how the two jointly interacting with the methods or constructivist learning environment. So now it is a three-way classification. You may see this like that. So the two methods, two different kinds of creativity and two cultural background. This kind of combination possible, and each cell there are different groups. So we can compare the interaction effect of all these three variables together. So for beauty of the analysis of variance is that it can be used in two-way, in three-way also. Now come to study the interaction three-way is okay. Now we can also see this objective to compare the performance of students on understanding of science mathematics by adjusting the differential effect of their intelligence. So here intelligence is being used as covariate, and its differential effect, by using analysis of covariance, we can adjust and then compare the adjusted means by using this variable. So ANCOVA can also be used. These are the certain things, but the important issue is that till we frame the objective in that manner, we cannot use correctly and decide that which inferential statistics can be used. Now, the next thing which I want to share with you is that for using any inferential statistics, null framing or formulating null hypothesis is a must. In fact, by employing inferential statistics, we test that null hypothesis. Null hypothesis means hypothesis in negative form. Please keep in mind, null hypothesis is not a research hypothesis, but it is basically a statistical technique, testing hypothesis, which denial the things. Now there are two things important here. One is that denial is there in this hypothesis. Second important thing is that in a technically properly written null hypothesis, name of the statistical measure should also be written. For example, you may write there is no significant difference between the two means. I have mentioned no difference, as well as I have mentioned the name of the statistics means the means. Similarly, there is no significant relationship, or better to say coefficient of correlation between these two variables. So null hypothesis is being tested by using any inferential statistics. Now, how do we test it? For testing a null hypothesis, the important issue is that we have to fix or decide the level of significance. Level of significance means, as I pointed out earlier, that the entire inferential statistics is based on the principle of probability. So we cannot say with 100% surety. So we decide that up to what level of probability we want to say. For example, if I want to say something with a 95% of surety, that 5% may be not sure, then we call it that there may be what we are saying 5% chance is that may not be correct. So out of 1, it will be 0.05. So out of 100, 5%. So 5. So out of 1, it's the 0.05. That's why we call it 0.05 level of confidence or level of significance. Means whatever we want to say, we are saying with 95% surety, means my level of confidence is 0.95 and level of significance is 0.05, that 5% chance may not be correct. No, if I am increasing the level, that I am not tolerating the 5% of possibility of error or missing, but I am interested, the maximum I can tolerate 1%, that whatever I am saying 1% is not correct, then my level of significance will be 0.01. Now, please keep in mind, for any measure of inferential statistics, will be higher at 0.01 level as compared to as 0.05 level. So to have level of significance higher, we need high value of that inferential statistics to come. Now, the issue is that at which situation we should keep high level of significance and at which level we should have low level of significance. The answer is not straightforward, but the answer is it depends upon the purpose of your research that will decide that you should keep the high level of significance to reject null hypothesis or low level of significance to reject null hypothesis. Why? Because there are possibility of two kinds of errors when you are fixing the level of significance. One kind of error which we call the type 1 error, or we call as alpha error. As I said, that the beauty of inferential statistics is it can tell you the kind of error likely to be committed when you are predicting something, when you are estimating something. The first type 1 error or alpha error appears when we reject a null hypothesis when it is in fact true. Rejecting a null hypothesis when it is in fact true. And when it is possible that you will reject a null hypothesis easily? When you have a low level of significance, because then for a lower value of a statistical measure, you can easily reject the null hypothesis. So if you keep the low level, the possibility of committing type 1 error will be more. But on the other hand, the error due to retaining a null hypothesis when it is in fact false, automatically retaining a null hypothesis will be opposite to rejection. That's why if type 1 error will increase, automatically type 2 will decrease. But if type 1 error will decrease, automatically type 2 error will increase. So what type of error you are ready to tolerate will decide the nature of your research. For example, if you are doing an exploratory kind of study, means your findings of your study will lead to further study by you or the future researchers. If you mislead them by giving a kind of that X is better than Y, perhaps all future efforts will be misled. In that situation, we should keep the high level of significance so that there is little possibility of rejecting the null hypothesis, and you are very sure if you are rejecting that, yes, this will most probably will happen. But suppose if you are doing a kind of research where two things you are comparing and most possibilities that two are equal, even if keeping the lower level of significance, if you reject the hypothesis, the maximum mistake possible is that you will substitute by the similar kind of thing with other. But there will not be any future long-term problem arise. In nutshell, what I want to say, that it is the nature of a study that will decide that whether you should keep a low level of significance for rejecting a null hypothesis or high level of significance for rejecting a null hypothesis. Please keep in mind that in all inferential statistics, you have to frame the null hypothesis. For example, if you are using a t-test, you should have to formulate that there is no significance difference between the mean 1 and mean 2. If you are comparing, or if you are interested to judge the significance of correlation, you may say there is no significant correlation between variable x and variable y. After testing this, you will keep this null hypothesis accepted or rejected. If you reject the null hypothesis, and null hypothesis will be rejected only when the calculated value is higher than the value required for that level, which is already fixed and given in different tables. Now the last thing which I want to say, that the selection, the testing of null hypothesis may be in two ways. One we call as one-tail test, another we call as two-tail test. For example, if I say there is no significant difference between mean A and mean B, and if it is being rejected, it means it may be possible that it may be higher or it may be lower. Means your area of rejection is both sides of the normal curve. But if you are taking the area of rejection merely only one side of the curve, that A is not better than B. Mean A is not higher than mean B. It means you are not taking the lower side, you are only taking only one side. So it's not only that there is no difference, but A is not greater than B. B means if you are rejecting this, there is no possibility that it will be lesser than this. So both sides of the rejection will not be possible. It means sometime, and most of the time, we generally put the two-tail test, means area of rejection is 2. It means null hypothesis in a no difference form, but we sometimes test this in a one-tail test where we use that direction is also given in the hypothesis. There is no mean of group A is not higher than the mean of the group B. It means I am giving direction to this hypothesis. Then we can use the two-tail test, the one-tail test, sorry. I think that's all from my side. But if you have any queries, anything further clarification, anything you want to supplement, you are most welcome.
Thank you, sir. Thank you for the deliberation. There are certain questions and the queries of some of the participants so far that has come. Ojit wants to know. Ojit wants to know that many a times he finds that the statistical tool is not doing justice to what is found in empirical data, and there when his understanding collides. So he wants to know that whether Madame Curie sensing a phenomena of radioactivity, or Newton of gravity, or Alexander Fleming's of penicillin are a chance favor.
Okay. What you are raising,
already
that is
described.
related not about the statistical method, but it is basically the limitation of the positivist paradigm, rather than just talking about the limitation of statistics. I am citing you one example. Suppose I said that the tool to measure any characteristics in quantitative paradigm ideally should be in a closed form, yes/no form. Let me elaborate this. Suppose I am working in a tea industry and in a R&D division, and I have to popularize a blend of tea. And for that purpose, I am doing a survey. And for that survey, I developed a questionnaire. And I am sharing with you only one item of that questionnaire. The item is, would you like to take tea just now? And I said the possible answer is only 2, yes or no. And I decided that if I will score yes, it will be 1. And if I scored no, it will be 0. Now take the example of 3 persons. Maybe Professor Loknath Mishra, when I gave that question to him, and he took just 2 minutes before 1 cup of tea, and that's why he said no. And since morning, he has already taken 8 cups of tea. And because last cup of tea he took just 2 minutes before, and that's why he refused to this offer. A second person, maybe Dr. Sajjad Ahmad, and he also said no. And he said no because he has just taken a homeopathic medicine, and his physician said that you can't take anything before and after half an hour except water, even not tea. And that's why he refused to take tea. And Professor R.K. Mohanty never take tea, and that's why he refused to take tea. All 3 said no, and I gave 0 to all 3. But take the example of Professor Loknath Mishra. He took 8 cups of tea since morning. Perhaps there is no better customer than him to purchase tea, who is already taken 8 cups of tea until night. Perhaps he will take more, 5 or 6 cups. But because that moment he said no, that just 2 minutes before he has taken the tea, and that's why he is saying no. But in a quantitative research, we are not taking into consideration these things. And this is the limitation of statistics. So please treat that statistics is your slave. Don't use it blindly. It's your wisdom as a researcher that will decide that what type of statistical technique, when that statistical technique should be used.
Very nicely.
You are satisfied with my answer?
Yes, sir, very nicely elaborated. And I think that another question of Shantanu Patra I am taking, he had 3 questions.
Yeah, please.
And first question of Shantanu is how to select parametric and non-parametric statistics. Second question, if the criteria is only normal distribution, then how to know it as normal? And the third question that he wants to know, how the extent of difference in values of mean, median, and mode be considered.
Please repeat, last one. How to?
How the extent of difference in values of mean, median, and mode be considered.
I think so far the answer of the first question is concerned. If you might have listened my statement, I have already identified that there are 3 things that will decide that which statistical technique we are using to use. The first is the way you have formulated the objective will clarify that you are moving towards which statistics. Second thing is that whether you have followed any kind of probability sampling technique, that will decide that whether you are moving towards which kind of inferential statistics. Third criteria will always be automatically that kind of tool, what kind of responses we can collect from that tool. For example, if you are using a Likert kind of tool, which is based on scaling, and if you are using a kind of tool which like achievement test or intelligence test, the nature of scorings are different. Because in scaling technique, there are categories fixed. So now you have to defend when you are using a particular statistical technique that whether we can transform these scale in the forms of actual score or not. For a standardized tool of attitude scale or interest inventory, there are certain clarification that yes, in spite of having scaling, it can be transformed in the forms of scores, and that's why we can treat and calculate mean or any other statistics. But if you yourself developing and you are having some caution that scaling cannot be transformed in the form of actual scoring, actual continuous scaling, we cannot use this. Second question is very specifically I cited that it's not only the one assumptions regarding the normality, but there are at least 3 assumptions that will decide whether we can use a parametric statistics or not. First is definitely normality, second is randomization, and the third is homogeneity of variance. So all these 3 characteristics are if being fulfilled, only then we have the test for calculating whether the distribution is normal or not. But for all practical purpose, unless and until we do not have any serious doubt about that the distribution is not normal, we treat them as normal. And these assumptions are not about the sample. One thing which create confusion in the mind of many of us many times, that these assumptions are not about the sample. These assumptions are about the population from where these samples are drawn. So the parent population are actually normal or not. So it's not just confined to the sample, but if samples are drawn in such a manner that it will definitely be skewed, then we cannot use. Otherwise we can use. And the last question regarding variations of mean, median, mode.
Yes, sir.
Last question.
How the extent of difference in values of mean, median, mode be considered?
It's not clear to me. What do he mean?
Basically, he has written, Shantanu Patra has written how the extent of difference in values of mean, median, and mode be considered. So he probably, I mean, I'm also not clear about what exactly he wanted to know.
Just from my own guess, I'm not sure about what actually he means, but there are 2 things. One is that to what extent the variation can be considered that it definitely deviates from the normal. Because in a normal distribution, all should coincide. So all 3 should have the same value. This is one thing. But if there is a very severe deviations of more than at least 1 standard deviation, perhaps then only we can say that it's definitely not a normal distribution. But the second kind of thing is that, as I pointed out, that all the 3 measures of central tendency should be calculated in all situations is not required. But it depends upon the situation that which measures of tendency is more appropriate to be calculated. For all future analysis, and when particularly we are using inferential statistics, perhaps mean is the most dependable measures of central tendency. The only exception is that when the distribution is having very extreme scores. Otherwise, we always prefer to calculate mean, because all subsequent analysis using standard deviation and all are based on this. But if you are analyzing on the basis of rank or position, then obviously we can go for the median. And as I pointed out, mode is a very crude kind of measures, which generally for future calculation we do not use, but if we need a quick view of the measures of central tendency, only then, and particularly when a distribution is bimodal, having two modes, then it is of a little meaning for depending on mode as a measures of central tendency. Next.
Thank you, sir. Next question that is from Jolly, and her first question relates to directly to the statistics, and second is little tricky. So, can we take null hypothesis and alternative hypothesis together in a research proposal?
Here, null, as I pointed out, that alternative hypothesis is basically very near to the research hypothesis. But alternative hypothesis you cannot write in the beginning, because alternative hypothesis will come only when your null hypothesis will be rejected. So if null hypothesis is not being rejected, how can you write an alternative hypothesis? But definitely you should write, not may, you should write the research hypothesis.
Right. So second question that she has raised is, why do our supervisor most of the time suggest to take null hypothesis in quantitative research?
It is very clear.
There's a lot of questions.
Very forcefully I said that all inferential statistics requires the null hypothesis. Through null hypothesis, we test the significance of any inferential statistical measure. That's why it's the prerequisite for testing the inferential statistical measure. That's why we have to write the null hypothesis. But please keep in mind, null hypothesis is no way a research hypothesis, but it's a purely a statistical testing hypothesis.
Yes, sir. So next question is of Pavan, and he wants to know whether any difference exists in statistical calculation by the software and manually doing that.
I'm not competent enough to evaluate the software, but definitely the software can do a more precise calculation as compared to manual calculation, because in manual calculation we many times give the rounding, and in rounding sometimes there is a variation with the manual calculation and the software calculated value. But to my understanding, if the software is not effective, it will give more accurate calculation as compared to the manual calculation, where we do many types of rounding also.
Thank you, sir. And next question is basically from the deliberation itself, where you had utilized the term possibility of sampling and probability of sampling. So whether they are possibility of sampling, taking up the second session, you had mentioned in the inferential statistics when you were deliberating. So two terms you had simultaneously utilized, possibility of sampling, and somewhere you utilized probability of sampling. So whether these are the term interchangeably used?
I don't think that I appropriately use is possibility. Maybe a slip of tongue, I'm not sure. But the possibility of sampling means, if I used, I mean perhaps that whether we can ensure to get that kind of sample which we have selected. Means whether we are using actually the probability technique of selecting the sample or not. But I forget actual what word I use and when I have used it.
Right, sir. So I mean, the clarification from Santu Patra has come that you were mentioning that if the normal distribution, in the normal distribution, when the mean, median and mode will be the same value, but not always. So in that respect, I asked
Normal
how.
distribution, it is always. Please keep in mind. Theoretically, normal distribution, this is the definite the characteristics of normal distribution, that mean, median, mode coincides with one another. So theoretically it is, but the important thing is to what extent we can tolerate. That is the issue. And that is to some extent a subjective judgment which the researcher makes on his or her own wisdom. But
Right.
theoretically there is no any confusion that ideal normal distribution should have the same mean, median, and mode.
Yes.
Yeah.
So I think that question is over now, and this is just the time that I should say thanks to you.
Yes, sir.
But indeed, sir.
Thank you, sir, for giving your valuable time. On behalf of Faculty Development Center, I welcome you and thanks you also for a valuable talk of giving statistical analysis without any calculation. So thank you, sir.
Not sure whether it's a positive comment or negative, but anyhow.
No, it is positive. It is
Sir,
positive.
That's fine. I did that because
So many people, those who do not know calculation, was from not science background, or they are very praised that you have delivered your speech without any calculation. Thank you, sir. So I welcome Dr. Sajad also to propose a vote of thanks of his. Thank you, sir.
So
Sir,
just one sentence more from my side.
Yeah.
Thank you, and I'm particularly thankful to Professor Loknath, you that though we are not interacting face to face, but after a long time we have this opportunity to interact with you also. Thank you so much.
Yeah, yes, sir. Sir, you have visited Bijnor, Vivek College, Bijnor, while I was the principal.
I remember.
Yes.
Thank you.
Thank you.
Thank you,
Sir,
Dr. Sajad.
Yeah, indeed, it was a very enriching deliberation, which has made the statistics to understand in a very easy manner. And I have been receiving the personal message from several participants in my personal chat box to thank you on their behalf, where most of them have appreciated that several intervening complexities of the statistics has been easily made understood to them, and which are so far and far from their comprehension. One of the chat that I will read out, sir, okay, for the first time I could learn that the statistics analysis can be taught without using of the formula, calculation, and measurement. I have got what I wanted, worth emulating. So these types of chats are coming, sir, and indeed, whatever you have done, that everyone is not so privileged to have the resource person like you. And I thank Loknath Mishra also, that throughout the country, he keeps on thinking which person will be the best suitable resource person. And in that, I was so much pressurized, and I ultimately pressurized you to come and give a talk to at least to the best mind that are participating here, sir. So on that, on behalf of the Faculty Development Center, Mizoram University, and on behalf of all the participants, including myself, which has learned a lot of things from you, sir, at every steps. I thank you from my core of heart to be here, take out your time from your busy schedule. I know that you had lots of work as a dean and a head, and lots of pressure from at least on you. But still you have carved out time to make this particular deliberation so easy for people who are not from the mathematics background or the statistics background and the science background. So they have also understood that, and the chat box speaks about that, sir. So thanks a lot for being here, sir, for deliberation. Thank you, sir.
Thank you, sir.
Participant also. Thanks, sir.
Thank you.
Thank you, Mohanty Sahab also.
Yes, sir.
Okay, bye.
Bye. So we will meet tomorrow by 2:30.
Yes, sir. Yes, sir.